All right, so now that we've learned how to calculate price elasticity of demand, we can classify different values of the elasticity of demand. So the first classification is elastic demand. So I'm actually going to draw out a little number line here. So basically, we know that it can only be negative, right? And we're, for the most part, going to ignore the negative, right? So it can range anywhere from 0 to negative infinity, or just infinity, ignoring the negative sign, right? So those are the values that the elasticity of demand, price elasticity of demand, can take on. Anything from 0 up to infinity, ignoring the negative sign. Now, elastic demand, we can say that a good has elastic demand if the price elasticity of demand is greater than 1, right? So here's 1 on our number line. And so anything in this region here, if EP is in this region, we say that the good is elastic, has elastic demand. Okay. Let me switch back over to the doc cam so you can see that better. Right. So anything in this region, if EP falls anywhere in this region, EP falls anywhere in this region from 1 to infinity, we say that that good has elastic demand. And what that means, as we'll see later on, is that in terms of expenditures, which, as it turns out, equals revenues, but we'll stick with expenditures for now, it means that total expenditures and price are inversely related. Okay, so when demand is elastic, price and expenditure move in opposite directions. Okay, so that's what that means. So in other words, and really this has to do with the responsiveness, right? So if it's elastic, it means people are very responsive to price changes. Another way to think about elasticity is in terms of flexibility, right? So if you're very elastic with your demand, you're very responsive, it means you're very flexible, right? So if there's an increase in price, it means that you're going to really drastically decrease how much you purchase. And so that's why price and expenditure are inversely related, because you're really responding strongly to the price change. And so if price goes up, even just by a little bit, you're gonna very strongly respond to that, reduce your consumption, and therefore spend less money on it, even though the price went up, right? So that's what it means when demand is elastic and total expenditures and price are inversely related. Now, when EP exactly equals 1, we have a special name for that. It's called unit elastic. And it basically means that when it's exactly equal to 1, total expenditures completely unrelated to price changes. So it doesn't mean that you don't respond. What it means is that you respond in exact proportion to the price change, right? So if price goes up by 50%, you decrease your consumption by 50%. And so the increase in price is exactly offset by the decrease in quantity, and you end up spending the exact same amount of money. And then the last region here is where it's between, EP is between 0 and 1, and that's the inelastic region. So if EP is less than 1, we say that demand is inelastic. So consumers are not very responsive to price changes. And when that happens, it basically means that total expenditures and price are directly related. They move in the same direction. So, and that's because, if price goes up, and you don't really change how much you purchase, you're not very responsive to that price change. Because the price went up, you're going to end up spending more money if you don't buy less, right? So that's why with inelastic demand, total expenditure and price are directly related. They move in the same direction. And this can be summarized here. So basically, when we have elastic demand, the percent change in quantity is bigger than the percent change in price, which is why EP is greater than 1. And so again, this is, high level of responsiveness. People, price goes up 50%. People decrease their quantity demanded by 80%, right? A much bigger reaction in response to the price change. When a good is unit elastic, the percent changes in quantity are exactly equal to the percent change in price. So there's no change in expenditure there. This again would be like if the price went up 50%, you decrease your consumption by 50%. And so they exactly offset one another and you end up spending the exact same amount of money. And then the last one, inelastic demand, this is when the percent change in quantity is less than the percent change in price. Again, when consumers are not very responsive to price changes. And so if price goes up, they end up spending more money because they're not really being flexible, right? Again, you can think of it in terms of flexibility. If demanders are inelastic, they're inflexible, they can't really respond to price changes. And so if price goes up, they will end up spending more money. If price goes down, they'll end up spending less money. So those are the regions. Now, we also need to talk about the extreme ends, right? When EP is 0 and when EP is infinity. So when EP is 0, right, this extreme end, that's called perfectly inelastic. Perfectly inelastic demand, right? There's absolutely no response to the price change. Quantity doesn't change at all. And so what you get in the top of our fraction is percent change is 0, right? And of course, 0 divided by anything is still 0. And so again, what this means is that there's absolutely no response to a price change. So quantity demanded stays exactly the same, no matter how the price changed. So that's one end of the spectrum. Graphically, it looks like this. It's a vertical demand curve. So again, it means that quantity does not change no matter what the change in price is. The other extreme is perfectly elastic demand. And that's when we get an elasticity of infinity. So this is perfectly elastic. All right. Hopefully you can read that. And in this case, we've got a demand curve that is horizontal, perfectly flat. So the reason it's infinite is because even a very, very tiny price change basically leads to an infinite change in quantity demanded. And I could illustrate this for you with an interesting thought experiment. So suppose I had a dollar bill, right? A $1 bill with George Washington on it. And I told you, I said I want to sell this dollar bill to you, and I'm going to charge you $1.01. How many would you buy? Hopefully you're thinking, well, I wouldn't buy any, because if I did, every time I bought a dollar bill from you, I would lose a penny. So why I would buy $0 bills from you at a price of $1.01. And I'd say, okay, you're not going to buy any from me. What if I lowered the price to 99 cents? How many would you buy then? Well, if you're really clever, you would buy infinite, right? You would buy one from me, turn around, buy another one from me, and keep going, because every time you bought a dollar from me for 99 cents, you would earn a penny. So you see there, the price change was really small. I went from $1.01 to 99 cents. So the price change was 2 cents. roughly a 2% change in price, but your quantity demanded went from 0 to infinite, right? So an infinite percent change. So that's basically the most realistic example of a perfectly elastic good I can show you is a dollar bill. But it basically ends up being a horizontal demand curve, and it has a single price for every quantity, right? So a dollar bill should be only $1, right?